Okay, so here we are still in Unit 1, Lesson 4. And a part of that lesson is point 2 called Shape Up. The questions that we're going to answer in this section are: how does particle motion affect the properties of solid liquids and gases and plasmas? And what happens when substances change state? We'll actually probably save most of the second one for the next lesson that we go over, which is called Changes in State. So in your textbook on page 8, you have a few questions that want you to look at the fish tank and answer some questions. In your guided notes, you have some spaces to give the characteristics of the states of matter that we're going to talk about. And on the right of the area of where you have to describe and give their characteristics should be examples to help you understand that characteristic. So we're going to start out with a solid. If you notice the animation in the upper left-hand corner, a solid has very distinct characteristics that distinguishes it from a liquid, a gas, or a plasma. So here is a scanning electron microscope view of gold particles. Notice that they are in an organized pattern, or they're just not randomly associated. So they're just not, one's here, one's there, one's over there. They're in a nice packed pattern. So a solid has a definite shape, which means that shape is fixed. So for example, my hand is solid, and it would be hard for me to change the shape of my hand. My coffee cup is solid. I can't just push on it and change its shape. And it has a definite volume. And so the animation of the coach here has him ripping a phone book in two. But when he's finished, that phone book is still a solid. And it takes a lot of force for him to change the shape of that phone book. It isn't that he just goes whoop and is done. So solids have a definite shape and a definite volume. Another thing about solids is that the particles are in a fixed position. So the animation on the left, you can see that they're all in that square formation. None of them are escaping, none of them are moving around. They are moving, they're vibrating in place, but they're not moving like going 3 centimeters to the right or 1 centimeter up. Just like the animation that's on the screen on the right, you can see that the atoms are in a fixed position, and the one that's highlighted is still moving, but it's not going very far. It's fixed in that location.